In this video, we'll be talking about collecting like terms. On your screen, you should see an arrangement of some algebra tiles. They're in no particular order. See if you can find a simplified expression for the arrangement of algebra tiles that you see in front of you. Do you remember the zero principle from grade 8 math? The zero principle says that if we can match up a red tile with a blue tile or a positive tile with a negative tile, they cancel each other out. When we can't match any more tiles of a type, well, we're done our matching. You notice how I can match up some of these tiles together, making them cancel, positive and negative together. If I keep doing this, eventually I'll be left with a simplified expression for the algebra tiles that I laid out in front of you. In this case, that expression would be negative 2x squared plus x. So visually, we were able to cancel out algebra tiles when we had a positive and negative pairing. What we're really doing is something called collecting like terms. Like terms are terms that have the same variable and exponent. Like terms do not need to have the same coefficient. So like terms have the same variable and exponent, but do not have to have the same coefficients. So for example, if I have a term like 2a, I could list some other like terms by making sure I keep the variable and the exponent attached to the variable the same. So 5a, negative 3a, or 0.25a are all like terms with the term 2a. If I had the term y squared, some like terms with y squared might be 1/2 y squared, or negative 600y squared, or 9y squared. Could have more complicated terms like the term x squared y cubed. As long as I keep the variable and the exponents attached to the variable the same, I'm looking at a like term. So when we're simplifying polynomial expressions by either adding or subtracting, what we do is collect like terms. As an example, if I have the polynomial expression 11x plus 4y minus 7x plus 6y, the first thing I can do is look at this expression and think to myself, which terms are like terms? Which terms have the same variable and the same exponent attached to the variable? I've underlined in green one set of like terms, and in blue I've underlined a second set of like terms. So I'm going to collect these together by writing the like terms side by side. Notice that when I did that, the sign that was attached to the term moves with it. So my term negative 7x stays negative. I'm moving the sign of the term with it. So when we collect like terms, we keep the signs with the term. And I'm not quite done yet. Now that I've collected like terms, now that I've grouped them side by side, I can add them together or subtract them. So in my case here, 11 x's take away 7 x's leaves me with 4 x's, and 4 y's plus 6 more y's leave me with 10y. So I'm adding or subtracting the coefficients. Let's try an example with a few more terms. You can see my polynomial expression in front of you. 8 terms. I'm going to start by identifying all my like terms. I see a term with a 2a, a 5a, and then further down the list, 6a. These are like terms since the variables are the same and the exponents attached to the variables are the same. I see a term 3b. I can't find anything else like 3b. I see 2 coefficients all on their own. They'd be like terms. And then lastly, a negative 2a squared and a negative a squared. So I'll rewrite this whole expression by grouping the like terms together. Remember, we keep the sign of the term together as we move it. I rewrote this expression in a specific way. As I rewrote this expression, I keep the variables alphabetical. So A comes first in the alphabet, so I write any term with an A in it first. I also write my expression from the highest degree to the lowest degree. So I started with the a squared term, and then I wrote the a terms, and then alphabetically I move on to b, and then I move on to terms without letters. And now I add each like term together by adding the coefficients. So negative 2, take away one more would be negative 3a squared. 2, take away 5 would be negative 3, plus 6 would be positive 3a. I have no other terms to add to the 3b term, so it just stays the same. And then I add 9 and 6 together to get 15. One last example. Again, we can start by identifying the like terms. So I see a x squared y term and another x squared y term, and then 3 terms that are just strictly x and y's together. So I can rewrite this by grouping my like terms together. And remember, the sign attached to the term goes with it. And now I add my like terms together or subtract them from each other. 2 take away 6 would be negative 4 x squared y. 4, take away 3, take away 5 would be negative 4 xy. So just to summarize, like terms have the same variable and exponent. They do not have to have the same coefficient. When we are simplifying polynomials, when we're collecting like terms, we can start by looking at our expression, identifying any like terms, and grouping them together. Notice again that the sign stays with the term. I then add or subtract the coefficients of like terms from each other. 5 take away 3 is 2. A squared. 2 plus 1 is 3ab. Again, I add or subtract coefficients only. And once I've done that, I've simplified my expression. Notice that as I was solving, I've been working down, not across. And notice that the equal signs all line up. That's part of good form.